All right, today we're going to talk about graphical transformations. Graphical transformations. Transformations. So this would be part one. Okay, so graphical transformations. So what we're talking about here is that when you did geometry, in geometry you learned how to move things around. We did reflections, we dilations, we did translations and this kind of stuff, right? So we moved like stuff around. So the first part today we're going to talk about just strictly translations. And translations is what? You keep the same shape and you just move that around within the coordinate plane, right? So if I had y is equal to x squared, all right? If I start with y is equal to x squared, all right? And let's say I wanted to move this up 2. How would I do that? Can anybody tell me how to do that? How would I move this up 2?
You do y equals x squared plus 2.
So you do y is equal to x squared plus 2. So you get y is equal to x squared plus 2. And you would go like this and it would just move up like that, right? So this would be 2. And you took this parabola and you just moved it right up, right? So that's easy. Okay, that one's easy. What about moving it 2 to the right? How would I move it 2 to the right? So I want to move it 2 to the right. Would be over here. Look like that. So what would the graph, what would this be? So this would be y is equal to x minus 2 squared, which makes sense because if you put x equals 2 in here, right? If I have x equals 2 in here, y would be 0. So it has to go through the point 2 and 0 right here, right? It has to go through this point, 2 and 0, okay? All right? So here's the thing. If you look at your book, and go to page 130, in the middle of page 130, it gives you a blue box there that says translations of graphs, okay? So horizontal translations, if I'm going to move it horizontally in the x direction, okay, if I want to move it to the right, where x is, I put x minus 2. If I want to move it to the left, I would put x plus 2, okay? And that is in the first one, the horizontal translations, which is great. The vertical translations, however, I do not want you to try to remember these in the fashion the book shows you, okay? Generally, people think that moving things to the up or moving it to the right are both in the positive directions. So in a positive direction, you want to move wherever x. So if you're going to in the x direction, you're going to the right, okay, you would go x minus c, right? With the y, if you're going up, I want you to put the same y minus c, okay? So what you're doing is that instead of adding the 2, you would view this as going y minus 2. Okay, so where y is, you're going to put, if you want to go up c, you're going to go put y minus c where y is. Okay, and the end result is when you move the 2 over, y is going to be equal to x squared plus 2. Okay, it seems like a small thing, but it takes away a lot of the confusion. Okay, so when it says vertical translations, and it says a translation up by c units, I want you to, in your mind, remember this. Y, where y is, you're going to put y minus c. Okay, so when you're going down, if I want to go down 2, okay, where y is, I'm going to put y plus 2. It's going to look like that. And if I move it over, it's going to be y is equal to x squared minus 2. Okay? All right. Again, feels like a small thing, but it makes your job or your remembering that much easier. Are we too far away? Are you able to see this? What do you guys think? You guys want, we good?
Possibly.
Okay, so you want to come up a little early? Is that better?
That's much better.
Okay, all right, we'll see how this works. Okay. All right, so the horizontal translations. If you're gonna go up, you're gonna where y is, you're gonna put y minus c. If you're gonna go to the right, where you on the x direction, you're gonna where x is, you're gonna put x minus c. Okay? So let's see if we can use that and we can do example number 1. So example number 1. A, it says describe, so if I start from this and I end up with this, okay, what did I actually do? If I move the 4 over here, it's going to look like this, right? This is what actually happened. So where y used to be, I put y plus 4. That means that I must have went down 4, correct? I must have went down 4 from this. So if I start with this, and this guy looks like this, okay, then this guy's gonna look like what? Like that, right? That's what it's gonna look like, okay? And then we have the second one is y is equal to x plus 2. So where x is, I went, instead of x, I put x plus 2, which means that I shifted it in the x direction. But since it's a plus, it means I went to the left. So I moved it 2 to the left. So I start from this. I move it 2 to the left. It's going to look like that. Okay. Example number 3. Example 3. Each view in figure 1.74 shows a graph of y equals x cubed and a vertical or horizontal translation y2. Write the equation for y2 as shown in each graph. So A, we start from the dotted red line and then we went down what? What do? We went down 3, correct? So we started from this and we went down 3. So where y is, I'm going to put what? Y plus 3, right? So y plus 3 is equal to x cubed. Therefore, the end result is y is equal to x cubed minus 3. That would be A. Okay, and then in B, what happened? What did we do? Did we move it horizontally or vertically? Sam?
Yes.
B, what did we do? Do we move it? So in example number 2, if I start from the red dotted line and I go to the blue line, what did I do?
Well, you moved it horizontally
Which way?
to the left, it would
To the
seem.
left. So I'm going to start with this, right? And I'm going to move it to the left. So where x is, I have to put what?
Let's see. You would have to put Oh, it would be in parentheses. I know that. So
it'd be in parentheses, it's going to be x plus 2 or x minus 2.
it would be plus 2. Sorry,
X plus 2, that is correct.
The cubing factor was just really throwing me off. No,
Okay. It doesn't matter, right? Because it's still the same graph, right? Okay, you're still cubing it, but you're moving it to the left too, right? Because where x was, you put x plus 2. Good job. Let's go to the C. On C, okay, now I moved it which way? Kyle, which way did I move it?
Horizontally
Okay, which way?
to the right.
To the right. So how am I going to make that happen?
X minus 3.
So where x is, you're going to put x minus 3, right? So where x is, you put x minus 3 cubed, okay? All right, pretty simple, pretty simple. Okay, so that's that. Now let's talk about reflections across the axes. Okay, so reflections across the axes. Okay, so let's go ahead and look at that. So reflection across the axes is if I'm going to reflect something across the y-axis, okay? So let's say I have this and we're gonna start with this. Y is equal to x cubed. And I want to reflect this across the y-axis, right? If I'm gonna reflect it on the y-axis. If I had x here, right, let's say this is 1. If I'm gonna reflect this across the axis here, the y-axis, it's gonna come over here now, right? And this would stay the same, right? Wherever 1 is gonna be over here, it's gonna be -1, right? So I'm reflecting now across x-axis, right? So it's gonna look like this and like that. Can you see that? If I reflect the purple across the y-axis, okay? So where x is, I'm gonna put what? The -x, right? So where y is, I'm gonna put, so where x is, I'm gonna put -x, which is this guy right here. Okay, so when I'm reflecting across the y-axis, so reflections across the y-axis, where x is, I'm going to put -x. Okay, and if I want to reflect across the x-axis, okay, again, now let's start with this. I want to reflect this across the x-axis, right? What am I going to do? So I'm going to reflect it across this way, right? So it's going to look like this and this. In other words, where y was, I'm going to put -y. Right? Because this value at 1 used to be here. I'm going to go ahead and reflect it across here. So if this was y, now this is going to be -y. Right? Same thing over here. If I start with this guy here, where it used to be here, -1, I'm going to reflect that across the x-axis. So it's going to be over here. So in other words, when I reflect across the x-axis, I'm going to go ahead and change the y to -y. Okay, so I start with this guy. If where y is, I'm going to put -y, x cubed. So y is going to be equal to -x cubed. Coincidentally, they're the same thing, okay? I kind of chose the wrong thing here, but they're the same thing. But whenever you reflect across the y-axis, where x is, you put -x. And if I'm going to reflect across the x-axis, where y is, I'm going to put -y. Okay? So let's go and see if we can do some of these. Let's do example number 3. Example number 3, I want to do an example first, and then we'll go back to the blue box. So don't worry about the blue box, we'll come back to it. Example number 3. Find the equation for the reflection of this across each axis. So I'm going to start with f of x is equal to 5x minus y and x squared plus 3. So we're going to first, let's reflect across the y-axis. If I reflect across the y-axis, where x is, I have to put -x, right? So it's going to be what? F of -x, which is going to be equal to -5x minus y. I put -x here, it's still x squared plus 3. Okay, so if I reflect across the x-axis, Okay, where y is, I'm going to put negative y. So this is going to be y, right? This is y. So I'm going to put negative y is equal to 5. This would be your answer. So if I clean this up, I'm going to multiply both sides by -1. This goes away. And it becomes that. Okay. Now reflecting across the origin is nothing more than reflecting across the y and the x together. Okay. So when you reflect across the origin, you're going to go ahead and go the same thing here. You're going to go negative y. So this is across the origin. Where x is here, y is going to put negative y. Where x is going to put negative x. So negative 5y minus 9, x squared plus 3. This is reflecting across the origin. So again, I'm going to multiply both sides by -1. So that'll be your answer. Okay. Now let's look at the reflections across the graph. If you look at the reflections across, look at the blue box now. If you look at the blue box, across the x-axis, they tell you to put a negative over there. Okay, it's the same thing. So my way of teaching is that I'm going to go negative y is equal to f of x. Therefore, this becomes, the negative goes over here. Okay, so again, I would not want you to remember it the way they have it. I would want you to remember it as this. Okay, so wherever it's x, you're reflecting across the x-axis, where y is going to put negative y, just like that. Okay, when we're reflecting across the y-axis, okay, where if you're going to reflect this across the y-axis, where x is going to put negative x. Okay, reflecting across the y-axis is where x is, you put negative x. Okay, and again, the origin is nothing more than both of them, right? So where y is, you put negative y, where x is, you put negative x. Okay. So that's number 3. Let's do example number 4. Prove that the graph of an even function remains unchanged when it is reflected across the y-axis, right? And that is the definition of an even function, right? The definition of the even function is that when you reflect it across the y-axis, it stays the same because it is symmetric across the y-axis, correct? It is symmetric across the y-axis. So basically what they're asking you to do here is what? I'm reflecting across the y-axis, so wherever x is, I'm going to put negative x, okay? But by definition, the even function is that this is going to be equal to this, right? This is a definition of the even function, and therefore it is the same. Okay, it's pretty simple, really. Okay, all right. So let's cut it off right here, and we'll pick it up the next half hour. So let's go ahead and we'll cut it off right here.